Ratios. As I mentioned, this is a topic we spent a lot of time on last year, so it should be somewhat familiar. A ratio is a comparison of two amounts. So let me just turn the light on this so it quits freaking out. Okay. A comparison of two amounts. There are three ways we could write a ratio. For example, we could do it as a fraction, 7 to 4. Now maybe this means for every 7 boys in the class, there are 4 girls. So in my 6th grade class, there's a lot more boys than girls. I don't know what the ratio is, but it could be this. For every 7 boys, there are 4 girls. Now notice this is an improper fraction. If you write it this way, you leave it as an improper fraction. Because if I'm comparing two things, boys to girls, well, I don't want to turn it into a mixed number. What does 1 3/4 mean? If I'm comparing boys to girls, 1 3/4, 7 boys to every 4 girls. The other way you could write it, using the word 2, and notice I'm keeping the same order, 7 to 4, with the 7 coming first. Or we could use a colon, 7 to 4. These all mean the same thing. These are all just different forms of writing a ratio. Now, to do it in simplest form, the ratio might be given to you in one of these three ways. If you are asked to put it into simplest form, I'm going to suggest you look at it like a fraction, because you guys are used to simplifying fractions. So for example, if I said 32 to 48 was the ratio, and you're asked to put it in simplest form, you can leave it like this. But if it's hard to think about that way, the important thing is you keep the same order, 32 to 48. Keep the 32 first. And if you want to rewrite it like a fraction because it's easier to simplify, you can do it that way. And then we're simplifying it just like a regular fraction. Both of these numbers divide by 8. Does anybody, that's 1. You could try 2, you could try 4, you could try 8. There's an even bigger one. Vincent? Good. They both divide by 16. Now, if you don't figure that out, that's okay. Let me show you that if you divide them both by 16, you get right to the simplified version. But let's say all you could think of was 8. You didn't realize 16. If we divide them both by 8, then we're not done. So just like with a regular fraction, you always have to look at your answer and go, could I simplify that more? Oh yeah, these both divide by 2, and then you can get to your final answer. So if you can think of the largest common factor, the greatest common factor, you get right to the answer. So again, if you're going to simplify, I'm going to suggest looking at it like a fraction. Now, this is kind of what we did last year with some other stuff. So let me show you how it's going to look different this year. First of all, you might be asked to simplify a ratio that has variables in it. This goes back to chapter 5. It's a ratio, 25x, we don't know what x is, to 20x, whatever x is. But it's also monomials. So let's think about, how could I simplify this? The numbers and the x's. CJ?
Divided by 5x.
Okay, so first, let's start with the 5. First of all, I could divide both these numbers by 5. And CJ mentioned the x. We could divide them both by 5x. If I do x divided by x, that's 1. 1 times 5 is 5. The other way, remember, we can think about it is, as long as there's no addition or subtraction, and I don't see any of that here, I can cancel from the top and the bottom as long as I do the same amounts. I can do 1x and 1x. Oh, guess what? They're both gone in this case. And again, leave it as an improper fraction, 5 to 4, because we're comparing two amounts. We don't want to turn it into a mixed number in this situation. Okay, let me do one more like that kind of combines some of these ideas of monomials. 9x squared y over 6xy squared. Now, we've already done this. Again, this was back in chapter 5. I think it was 5.3, dividing monomials. So let's start with the numbers. 9 and 6 both divide by 3, which leaves 3 and 2. And then if I look at the x's, what's the maximum amount of x's I can cancel out from both top and bottom? Pammy?
X.
Good. I can only get rid of 1 because there's only 1 in the denominator. If I get rid of 1 from the numerator because there was x squared, I've got 1x left over. What about the y's? What can I do to the y's, Jaden?
Divide 1
Okay, I can only get rid of 1 because there's only 1 in the numerator. And because there's 2 in the denominator, my extra y is in the denominator. Those x's and y's do need to be in the right place, numerator or denominator. So you look to see, well, where were the extras? And that's where the extra 1 stays. So that shouldn't be too hard. I think most of you have gotten pretty good at that. So that's all just simplifying ratios. So you'll have a few where you're simplifying. Now, there is a slight difference to be aware of if we have different units. And I'll show you what I mean. Different units make them the same. And I'll show you what I mean. These, we don't know what this stuff was. Is it cookies? Is it inches? Is it books? We don't know. So let's say, for example, I have 3 hours to 15 minutes. So first of all, I just, for a change, wrote this one with the colon instead of as a fraction. If you're asked to simplify this, but it has units, and those units are not the same, well, we can't compare them if they're not the same. Hours are not the same as minutes. So first of all, let me just suggest that again, if it's written side by side with the colon or with the word to, that you think about it as a fraction. I think that's going to be the easiest way for most of you to work on simplifying. Now, hours and minutes. I need to have the same units. Right? So when I said, if it's different units, make them the same. Well, these are different units, hours and minutes, I need to make them the same. If I try to turn 15 minutes into hours, I can already see Jalen's like, It's going to be a decimal or a fraction or something because 15 minutes is not a whole hour. I do not want to have a decimal or a fraction in my fraction. So here's what I'm going to suggest. Take the bigger unit. Hours are bigger or more than minutes. And we're going to take this hours and turn it into minutes. How many minutes in 3 hours? If there's 60 minutes in 1 hour, Carissa? 180 minutes. Now, once they're the same, you don't actually need to write the units anymore on the problem. You can if you want to show that you have minutes. Again, take the bigger unit and turn it into the smaller. Now that they're both minutes, now I'm just simplifying like I would a regular fraction. Okay? I'll tell you right now, both of these divide by 15. And so the final is going to be 12 to 1. Keep that 1. Normally we go 12 over 1. Oh, that's just 12. But what if this, and here's why we want to keep it as an improper fraction even with the 1. What if this said for every 3 hours of math homework, you get a 15-minute break? Oh, that sounds awesome. For every 3 hours of math homework, you get a 15-minute break. This is like math jail or something. Math punishment. So then we would go, well, what's 12? Well, really what it is 12 to 1. For every 12 minutes of math homework, you get a 1-minute break. So we're saying it in a smaller unit, that's all. So keep it as an improper fraction. Let me show you one more like that, just to make sure everybody's got it. What if it was 9 inches to 5 feet? Now, if you're going to do it like a fraction, you don't have to first write it the other way. You could just directly write it in fraction form, 9 inches to 5 feet. 9 inches. Wait, if I turn that into a foot, that's not a whole foot. There's 12 inches in a foot. So if I do inches, if I change that, that's going to be a fraction or a decimal. So let's keep the smaller unit. Inches are smaller than feet. Let's take our bigger unit of feet and convert it into inches. If there's 12 inches in 1 foot, Jim, 60 inches in 5 feet. Then once it's in the same units, we can simplify. These both divide by 3. So we get 3 to 20. Now you could write that as a fraction. You could go back to the colon. You could use the word 2. I don't care what format it is. When you get to these problems in the homework today, if there are any units you're not sure of, please ask. For example, centimeters and kilometers, or pounds and ounces. If you have any units you don't know about, please ask. I will tell you. Okay, now the only other thing that you're gonna do here is we're gonna work on proportions. I'll give you an example. Let's say that Courtney planted, you may not know this, Courtney's a farmer. Courtney planted corn and wheat on 160 acres of her farm. It's a lot of work, Courtney. If the ratio of corn to wheat is 3 to 5, how many acres of each crop did she plant? Now, of course, any word problems that I give you, you won't need to write down the problem itself. So this is the only one where you got to write it all down. So Courtney planted corn and wheat on 160 acres of her farm. If the ratio of corn to wheat is 3 to 5, so let's say for every 3 acres or every 3 plants of corn, she does 5 of wheat. How many acres of each crop did she plant? For this, we are going to set up a proportion. Let me remind you that a proportion is where we have 2 ratios that are set equal to each other, and we're going to cross multiply. Now, here's what we need to do. We use the ratio that we're given. What ratio am I given in the problem? Vincent? 3 to 5. We're going to keep it in that order. Now, it might help to make a little note. We did problems like this last year. I'm going to make a little note to myself. Here's corn, and here's wheat, just to keep it the same. Now, this one is a little different because I've got a total of 160. So first of all, before we get to our, oh, and actually, you know, I take it back. This one isn't really a proportion now that I say it. That's okay. I'm going to show you anyway. It's not exactly the same as a proportion. I was thinking of a different kind of problem. But let's first take a look over here on the side. We're going to make another little note to ourselves. If I have 3 to 5, here's corn to wheat. I'm just going to abbreviate. So we may not actually need a proportion. I take that part back. We're going to get to that later. And do this instead. If I know the ratio is 3 to 5, what if she only did 3 acres of corn and 5 acres of wheat, and that was it? How many total acres would she have? She planted 3 of corn and 5 of wheat, keeping that ratio in the same order. If she only actually did 3 and 5, how many acres did she plant, Diego? Just 8. But that's not what she actually planted. Her total was actually, oops, it's on the screen there, but a total of 160 acres. So I'm sorry, we're not doing the proportion yet. That was my mistake. That's tomorrow. Just kidding. So, if I know the 2 parts, 3 to 5, the ratio, let's look at our total. How can I get from 8 to 160? What would I multiply by, Leanna? Yeah, times 20. Well, if the total increases times 20, it's 20 times bigger, guess what? If I do each part of the ratio 20 times bigger, 60 and 100, it's kind of like I'm going from the simplified ratio to a bigger one. Instead of simplifying, I'm making it bigger. So notice that I knew the 3 to 5 and I knew the 160. So first I go, well, if it was only 3 and 5, it would be a total of 8 acres. But that's just the ratio, it's not the actual amount. The actual amount, the total was 160. So I figure out how would I get from 8 to 160? Well, it's 20 times bigger. So I make sure each part of the ratio is also 20 times bigger. How much corn did she plant? 60 acres. How much wheat did she plant? 100 acres. Okay, so if you have something like that, this is an example of how to solve it. Sorry about the proportion part, that's actually tomorrow, I got ahead of myself there. That's it.